Okay, I'm going to go ahead and get started. So we've got a few people on, so we'll cover a little bit of the housekeeping things. So welcome to Atomic Friday. This is Casey Smith. I'm on the applied research team here at Red Canary. Mike Haig is with me as well. We'll do some intros in just a moment, but let me, just for a couple of housekeeping items, can everybody see my screen okay? It should be broadcasting the slides. And then if you have questions, there's a Q&A panel. So as we go through that, feel free to drop your questions there. We do like to keep these interactive, so please feel free to interrupt, ask us questions. This is a little bit different than a traditional webinar structure, more like, think of it like a chalk talk or whiteboard session. So
cool. Yep, screen's visible, Casey. You're good.
Thanks, Mike. Okay, so let's get going. So a couple things we're going to cover today. Talked a little bit about some of the ground rules. So some people have been on Atomic Fridays before. Some of you maybe new. So we're going to just go over a couple things on connection proxies today, which I think you guys will find exciting. And we'll talk a little bit about a threat detection report that we recently released that really led to why we wanted to present this one today. We'll do a deep technical dive into connection proxies. A little bit of demo on how these things work, how you can observe them, some ideas on detection and Q&A. So again, I'm Casey. I'm on the research team here at Red Canary, and I'll let Mike, you can do a quick intro too before we get started.
Yeah, thanks. Mike Haig. I work with Casey here on the research team at Red Canary as well.
Awesome. All right. So with that, let's go ahead and get started. Some of you may know we recently released our threat detection report, and Mike and I and Keith and Kyle and Brian Donahue worked together to put information in this report that described what we had observed over the last several years of threat detections that we had mapped back to MITRE attack. So always a shout out to our friends at MITRE for developing that taxonomy, but the aim of this report was to help people answer the question, where do we start? And that was one piece of it. So we think this is a really useful thing for different teams. So we'll have some links later on, but we just wanted to just drive some additional data or context to that report. If you do have questions, I think you'll find it interesting. So
yeah, we cover the top 10 techniques top 10 attack techniques within that report. Each one is in detail. We give you like 2 different like actors who have used it in the wild, along with detection strategies. And so like for today, we're talking about connection proxy, which is the 4th one on our list here. So that's one of the reasons why we wanted to bring it up today to the crew and show some cool, fun techniques about it.
Cool. Yeah, I think it was kind of interesting as we actually started analyzing the data. Like this one surfaced, and it's a bucket for a number of different techniques. I think you would agree, Mike. Like there's things that are happening in connection proxy that fit their best, and that's how we categorize them. So we could have a discussion here on Atomic Friday about what was best or not best there. But I think it was kind of interesting to see that was certainly in the top 5 attackers tunneling or routing traffic through different network connections. And usually on these talks, they're endpoint focused, right? So a lot of the things that we're looking at is endpoint telemetry. But I think you'll find as we get into this with Mike, this is a good use case for blended coverage because there's a lot of things that are only observable from network perspective. So we'll get into that.
Yeah, that's definitely getting into writing this whole the whole report out, right? You wouldn't kind of consider connection proxy like one of the top ones. Yep. This sounds like such a random item compared to, you always think PowerShell and scripting and whatnot, and then there's connection proxy. Hang out.
People got to get data out, man.
Yes.
All right. Let's do this. Okay, so yeah, let's just dive in. Let me minimize my screen for just a minute and just tie this back to sort of the origin of connection proxy. So if you're not familiar with the MITRE attack framework, this is T1090. All of this is done by the great team at MITRE that collects this, creates this taxonomy. So you can go and look here for this data. We simply use this to classify different detections within Red Canary. And so one of the things I always like to point out on these techniques is the data sources. And so it's really interesting when you look at a technique and you start thinking, well, how do I defend against this? And what products would see this or observe this? There's a really good catalog here of different data sources. And so here you can see processes making network connections, process monitoring, some sort of PCAP or NetFlow or proxy collection. So there's some good things here that we can use to observe this. So let's see, what else do I want to say on this? Yeah, the other thing that they've done here is they've got good examples of groups that are actually using it. So these aren't theoretical things that are happening, and then there's always good references citing sources. So always encourage you to drive back to MITRE as the source for anything we're discussing, usually on Atomic Friday. So, okay, let's see. So Mike, I'll let you go ahead and kind of describe this. I'll bring this back in present mode. Why don't you take us through a couple of these different techniques that we've identified as connection proxies?
Yeah, totally. I might blend some like detection into this as well, because
Sure.
Tor is kind of an easy one. Yeah, so kind of following the T1090 technique page on MITRE. These are more or less just what I pulled out straight from kind of like that page, and it highlights what all different actors are doing or what is out there, you know, whether they're backhauling across Tor to kind of anonymize themselves, you know, or using I2P. You know, you could do SSH reverse tunnels. You could do a putty. Fast flux was very popular, might still be. Using dynamic DNS domains, just anything like that to kind of like obfuscate and hide themselves, and, you know, put in their code multiple things and just kind of like throw everybody off, and just use different ways to command themselves back. Probably the one that I tossed in here, it's actually not on the page for T1090, is domain fronting. And Casey and I had a pretty big discussion about domain fronting, because I looked at it as a proxy because it's a domain or a server, and if I C2 back, it hits that domain front, it's doing domain fronting, and then it reaches back to my, you know, my control command and control server at the end. It's not specifically called out, but that's how I kind of viewed domain fronting, and we had a good discussion on that one, huh, Casey?
Yeah, I think that one is one that one in particular is interesting because, you know, one of the common things we see adversaries do, or even red teams, is front through cloud content service provider. So like, you know, set up a host within Azure or AWS, and some of these some of these have locked this down. But you know, the idea is, if you're observing the network on the traffic on the wire, it looks like they're going to a legitimate service. But whether or not it's technically a proxy, I think that was really the spirit of the debate. It made sense to put it here. It's definitely a redirection technique or misdirection technique, I think, just like some of these other ones. That's kind of how I came to grips with it, if that makes sense.
Yep.
Yeah, NetSH is actually interesting. Some people know about this, but so a lot of people monitor for like a process like PowerShell making a network connection. And I was just talking to one of the folks on our detection engineering team this morning, and NetSH, you can actually set up like a listening tunnel, and so it'll receive a connection and then send it out something else. And we can look at this a little bit later, but that's a way to proxy through, like, all of a sudden your netcons are being made through SVC host, not through PowerShell. And so that's a way I think attackers like to break that single file bias, where if you can split network from process, it makes it a little bit more difficult to stitch that together and make a connection to say, are these things related in a particular way? So, and we'll show an example of that in a moment. So, yeah. That's cool. But NetSH is one of those commands, like command line auditing, right? You could observe, or even SSH commands or PuTTY. Yep.
Cool. Yeah, Tor. So I2P is on here. I don't know how many or how much everyone knows about I2P, but it's kind of similar to Tor. It's not exactly the same. Like, the idea of it is very much privacy focused and not completely intended to access ClearNet going through I2P. They even recommend on their site that if you wanted to access more ClearNet or use it as a proxy, use Tor. And generally, I think in most of investigations we've done, and we've always seen Tor usage more often. So you'll see like you go get the Tor IP list for all the exit nodes and whatnot, but you don't hear much about I2P.
Right.
I think once in the past I've seen I2P used at a previous job where it was actually dropped. The binary was dropped and they had access to I2P that way.
Yeah.
But it's definitely not heavily as often, and it's just something to kind of keep on the radar. But yeah, check out I2P if you haven't heard of it. It's different. It's going to be a lot slower than Tor because not everybody wants to kick up I2P nodes and all that fun stuff. But yeah, it's probably should be on a radar somewhere.
Would you say there's a different level of like ability or configuration to use I2P, or is it just like is it harder to use than Tor, or is it just like not that many people know about it, so it's just not used? You know what I mean? Like trying to distinct, like why would someone go I2P versus Tor maybe?
I think it's the readily available, probably the ease of use of Tor, right? Because like I can go to Tor's website, I download, the Firefox binary, and I'm ready to go, kind of thing. Where I2P is like, I got this cool Java front end. Good luck.
Yeah. Okay. That's what I was wondering. Yeah. Sometimes it's a barrier to entry if it's not not easy to use.
Yeah. And like we talked about earlier, it's like there's probably a bunch of these things out there, right? And who knows? There's all kinds of little dark little web things that people can get into and play with that turn into these things.
Nice. Cool. Awesome. All right. Anything else on this one? I think we're good on that.
Yeah, good, man. Your demo's next.
Okay, yeah. So kind of the thing that we like to showcase on Atomic Fridays are, so we know looking at MITRE ATT&CK, we know these things are happening, and we know that there are a number of ways to do them. So the question that we always try and answer, or try and answer often in Atomic Friday, is, so how do you detect it? How do you test for it? How do you observe it? So wanted to show you a quick live demo here of a particular one service. Again, there's dozens of these, but I think this one's nice for two reasons. One, it's really easy to use, and two, it's open source. And so this one gives you a chance to, in a benign way, exercise some of this type of activity. So what we've created here in this demo is we're going to use a service called Local Tunnel. You don't have to go there now. I can, like I said, we'll share out these slides, but Local Tunnel will advertise a URL to the internet to a service that's inside your network. And so what that allows an attacker to do is, this is really, think of it bidirectional. One thing they could do is they could set up like, think Metasploit, they could point a beacon or an interpreter payload to their local tunnel, which then routes back inside some secure or bulletproof hosting environment that they're living in. Or if you flip that around, an inside your network service could advertise a URL that then gives a backdoor. And I think the reason these things are really interesting is because there's no configuration by default on a firewall, NAT, or even a proxy. And so what you end up with is this really interesting inside out tunneling. So think of a secure environment, and there's no rules that allow outside traffic inbound by default to say whatever port. You could spire up inside of that environment local tunnel and connect right back in through RDP, SSH, or whatever you want it to run on the inside, and it's advertised like it's on the outside. So if that makes sense, that's what Local Tunnel is designed to do. And so it's a really good use case, but don't get stuck on the tool. There's a number of these, like Mike was saying. Just think about the pattern here and how you might be able to observe and detect it. So Local Tunnel actually relies on Node.js. And so it's a package you can install pretty easy, and it just forwards traffic from an inside port to an outside port. And then I just wrote a really simple web shell to demonstrate this, just so you could have something. We'll post this code. It may not make it into Atomic yet because there's a lot of moving parts here. And I want to Mike and I will probably just write our own thing to do this. But for now, this works. So without further ado, let's jump into the demo. Any questions before I jump into this? Does that make sense what we're about to do? If there's any questions, just drop them in the chat or QA. So, all right, so let's look at it. Okay, so this is an example of the test I was running just before the Atomic Friday started. Let me just kill it so you can see it from scratch. So in this example, Mike, just real quick, is my VM showing okay?
Yep, looks good, man.
Awesome. Okay, sweet. All right, so on the GitHub page that I posted in the Atomic Slack, this is just a Power Web Shell is what I called it. It's really trivial web shell. Let me just show the code so there's sort of no. Let's see here.
Yep, I'll also post this the gist location on the Atomic Slack as well. Okay,
so it's super easy. Like literally, like this is something I wrote just because I wanted to mimic a web shell, but I didn't want to have something really heavy that was a binary or anything. So it's really just like 60 lines of code or so. It sets up a listener here. So I'm going to listen locally on port 999. I just picked that arbitrarily. You can see that if I click on it, my local web shell is running. And if I go in and do shell here, I should get a little interactive prompt. And this is all just run through my machine. Pretty cool, but not all that helpful because no one can get to it from the outside. So that's where with a connection proxy or a local tunnel, we get some interesting behavior. So what I'm going to do here, and just so you know, I've already installed Node and I've already got local tunnel package. So it's really just a one-liner command to set this up. You would say local tunnel, the port, and then in this situation, our local port is 999. And so local tunnel is designed to really run HTTP services through. But what this will do is it will reach out to localtunnel.me. It'll dynamically generate a URL for me, or subdomain, basically, and then I can hit that from the outside world. So let's just give it a second here. All right, I was hoping it was going to be something that was appropriate. It's a serious earwig. Randomly generates a name. I don't have any control over that when I'm using local tunnel. I'll talk about how to set up your own service in a moment. And then in my VM, you can see I hit Hungry Puma earlier, but now I can go out here and hit my URL from anywhere in the world. I get ipconfig, and we can run our command and get feedback from it, or we could spawn cal.
I noticed too that it's even SSL you got running there as well.
It is by default. It's all tunneled over TLS, exactly, SSL. So makes it a lot more difficult to observe unless you're cracking that stuff open. So you get the idea. This, you know, as far as like triggering alerts, like this is just an example of a tool that's running inside of our network. I've got a couple of commands queued up there. You know, you see, we'll look at what this looks like in like Sysmon in a moment, but you start to see sort of the power. Like I didn't change anything in my configuration at all inside of my VM. So basically we were able to run that through NAT, through the firewall, behind a proxy, and get a, you know, touch an inside resource. So that's kind of that inside out piece that we wanted to talk about. So let me kind of pause there. Go ahead, Mike.
No, I was just saying, yeah, it's a clean, secure tunnel, non-standard port, right?
Yeah, I mean, and it looks like from like there's no inbound to 9999, right? Like you never see that on the wire, right? It looks like from your connection. Well, actually, let me just show you. I created a PCAP so I could explain this better. It's just Node reaching out and touching the, you know, remote machine. So like you can see like here, we can look up, there's some stuff I was running earlier. I'll show you in a minute. This is an example of like a custom server that I created. So let's just filter on this. So you can certainly run your own server. And so we've got a domain called OKTunnel. And this is just there's something wrong with my server, but you start to get the idea. Like in order to initiate the request, the local tunnel client just makes a request and says, give me a new domain, give me a new thing. And if I had it configured right, it would have all, you know, fallen in line. But so yeah, from a directionality standpoint, this one's a little bit hard to stitch together because it appears like some binary talking out, which is in most environments allowed. and then something is able to piggyback its way back in whatever they want to hit. So there's a lot of things they could do here. Web shell is one, RDP, SSH would be other things. WinRM, like whatever they want to expose outside, they could do that through local tunnel. So questions on that demo? Does that make sense? And now we're going to break it down and look at like, okay, so we ran the test, what's observable, what can we detect? But I'll pause there to see if there's any questions before I continue. Okay. They say it takes 5 seconds to formulate a question. So you don't want to just be like, are there any questions? Okay, no questions, move on. So, all right, fair enough. So to kind of recap, in this situation, in this example, we use Node, we use PowerShell, and we use a free open source tool called Local Tunnel. Now, what does that look like from a detection standpoint? Here's the steps if you want to recreate this test in your own environment to see what you're able to observe. These were things that I had done before. And like I said, we'll share this out. There's the sample code so you can get the PowerShell web shell. It's all there. And it's
I got that. I got to put in the Atomic Slack as well.
Okay, awesome.
Local tunnel link and the gist. Yep, all there.
Yep. So one of the things that's really interesting that shows up internally is, and this is, we like to use Sysmon as just a way to demonstrate observation on a host. So it doesn't have to be, you probably may have other tools. Some people use, like we use a lot of Carbon Black Response or in-game, some of these other tools, but you can see like here, Node is redirecting internally to a local port. So this would be something that you would want to think about. Like, again, that's this particular tool, but here you can see that one process is redirecting locally into another process. And so that usually doesn't happen. I always say that and I get proved wrong, but most of the time, right, Mike, I think we would see this like when developers are testing local services or
web app.
Like that. But on a, someone that doesn't have that as a job requirement or function, they probably don't need to be routing things from one process to another. But
it's kind of like, application baselining. If you have one of these tools out there, like a EDR or whatever, or even an inventory tool, right? Like all of a sudden Node or something like random tor.exe shows up on an endpoint inventory list. Like that's your point of interest right there. What's going on? What changed all of a sudden? And you go back and start reviewing those logs and you see a random non-standard port, guest IP, local host.
Yep. And we should actually probably, Mike, at some point do we could almost do a whole Atomic Friday on Node itself. Cause like a lot of people see Node.js and like, oh, it's just JavaScript. But what you need to realize is Node gives you full access to all API calls. And so Node is incredibly powerful as a scripting engine or host. Think of it as every bit as powerful as a binary or PowerShell. It's just the input is JavaScript, but there's libraries that let you do these type of things like port forwarding and arbitrary connections.
So if we're thinking about it, that means it's already in production somewhere.
Oh yeah, I mean certainly it's one of those factors that again it's often a trusted binary in a fleet that has a lot of power. Yep. Okay. So let's see. And you touched on this, Mike, but I'll let you kind of take the lead on this. Like, so these things are probably happening in different environments. Maybe you can take us through a little bit of detection. So.
Yeah. Yep. So we did outline a lot of this in that detection report we mentioned at the beginning. And so most of this is going to be focused on the network. And we talked a little bit about how you can at least get the Tor IP list, put that in, a SIM or just run it against a bunch of logs. Network logs, or a lot of NetFlow tools have ways to do lookups and whatnot. So yeah, at least gives you an option to be able to begin poking, looking for people hitting exit nodes or people hitting these IPs. And if you don't have like an endpoint based tool, you can, or if you do, you can then go back, look through those logs, find that process making those requests. If you start seeing random different applications hitting those IPs, at least you can start to like kind of drill in or remove those applications or confirm compromise on these endpoints.
And
we talked.
even though it's not like a specific network thing, right? Like, I mean,
Yeah,
most EDR products or endpoint products will log like the DNS name or lookup as a connection. So, right? I mean,
yeah, exactly.
very often you still get it even though you're looking at endpoint, and those can be interesting, like DNS inventory. Who are we
Yeah.
talking to, right?
Oh
Yep.
yeah. Like, I mean, even just simply looking for like the just different dynamic DNS domain names, like Zap2 and whatnot.
Yeah.
Like all of those, you can go get that giant list, do the quick lookup against them, and start to go back and find out. And that's actually a really interesting one. My previous organization, when random story. So like when we turned on Red Canary for my previous organization, one of the many first few things they caught was somebody using dynamic DNS to reach back to their house, using like a SSH tunnel, more or less reverse tunnel. And it was really interesting when we actually talked to the employee. He was an IT guy, and he was like, "Yeah, I reach back and I kick off my home backups this way." And we're like, "Oh, that's interesting."
Oh
just
man.
just random things, right? Like who would
Yeah.
have thought? But I mean, that's just one of the uses, right? And
Yeah, that's
yeah,
actually a good point. Yeah, because I know like one of the use cases early on too was like if you've ever had to like you see a malicious netcon or lookup, but then you always want to know what host and what process, right? You always want to tie that back, and
yeah,
so like you could shorten that cycle from a 30-minute exercise to really sub-second query to see, oh, it's whatever PowerShell on this particular host is talking to that domain, right? And that makes it huge as a defender, I think, to be able to quickly answer that question like you're describing.
yep.
Who, who's
Yeah,
talking over SSH or whatever? Yeah.
yeah, people, just it could be even just employees. I remember catching employees RDPing back to their house to do whatever,
Yeah.
bypass org controls to run that application I need to run that my business won't let me run or whatever.
Yeah.
But yeah, dynamic DNS is such a fun one to look for because, actors use it, general day to day, it's just out there,
Yeah. Probably too, if you're collecting network data, there's observation here like long running or large, transfers right over a particular like local tunnel will keep that open as long as you have the process. So like I don't have specific data, but there's some analytics around like should that socket be open for 3 days? Like is that normal? You know what I mean? Like
Yeah.
so there's probably opportunities there as well. So
Yep.
cool.
Yeah.
Okay, awesome. What else you got? Anything on this one?
We've already talked about inventory,
Yeah.
and I think that's, I mean, EDR or SCCM, right? Like it's just a good way to inventory endpoints, find out kind of like what's new out there and stuff, and do those comparisons. I think we do call out a section in the doc here. Yeah, even doing like egress, look at egress traffic by geolocation, port, and frequency. Um, Black Hills Information Security, they do a good talk on kind of like analyzing frequency of ports and whatnot, even by geolocation. They got their tool called Rita,
Yeah.
just for network analysis. Like it's such a neat way to look at network data. If you don't have anything today and you're curious, right, you could pull Rita down, throw your network data in there, and it'll just kind of more hopefully quickly start to analyze that for you and give you some pointers on where you can start looking. But
Yeah.
geolocation is
Yeah.
interesting. But yeah, go ahead.
Yeah, Rita's cool because yeah, it does some things like looking for heartbeats, like things that happen at exactly 60-second intervals, right? Like that's it's suspect, right? Because it's not a normal interval for like human interaction with the system. So yep.
And that's actually probably, I was just kind of thinking about an old NetFlow tool that we used to use, and like we have NetFlow and we're pulling all this data. It has like this cool graphical user interface, but like Rita's telling me frequency, exactly every 60 seconds. Like I don't remember some, like a lot of those tools that we have like with NetFlow at our disposal, it doesn't really go into enough detail or provide a security analyst the ability to kind of really analyze and dig deep into those things, because they're more for validating data's flowing and IPv6 is working and all that kind of stuff. And is it making a full connection or not? But like Rita, it can really help with just pulling that and yeah, just really analyzing stuff. Yeah, it's
Yeah,
cool.
and you actually mentioned something that I don't remember if we made it in our slide deck here, but Mike and I were working on some tests this week, and observability in IPv6, right, is it's on by default on Windows systems, and so thinking about like, does your tooling or telemetry even collect it? Like Sysmon has a really good job of like describing if you have IPv6, so it's aware. But some older tools may or may not actually surface that, and if they do, it may not be in a way that's easily searchable. So something to keep in mind too. So
That's definitely like it's almost like its own technique.
yeah, it's kind
There's
of
a lot there.
yeah. We'll file that one away another day.
Yep. We'll talk about that one.
Yeah. So yeah, so I think we're doing really good on time. We didn't have a whole lot, and like we said, we like these things to be interactive. So I'll kind of pause there and see if there's any questions. Somebody had a question of a live demo. I'm not sure. Maybe you could clarify what you mean by that question. I'm not sure.
I wonder if he came in a little later.
Oh, maybe so. Maybe so. Okay, that's fine. No worries. Yeah, so this was just for those who maybe joined a little bit later there. This was recorded, and so anything that we did up to this point is we'll post this on YouTube in a little bit. You'll be all set. So cool. Okay. Any other questions or thoughts? So we talked about a couple of things. Just kind of jump back to like our quick overview. Like we looked at the threat report as a resource for you all. We'll get that link out. Talk specifically about different connection proxy techniques. I think if you were to sum up connection proxies, it's to obscure or misdirect identification of traffic. So using alternate protocols, using different domains, using different systems to hide or try and blend in. Maybe it's a quick, succinct way to describe that. And then we talked a little bit about detection strategy. So I don't really have anything else at this point, Mike. If we have anything else we want to drop in here. Or...
Oh, hey, yeah, I think that's really it.
Okay. Yeah, so yeah, we try to keep these pretty low drag. Atomic Fridays are pretty lightweight. Just a quick, I'll kind of jump out and give you some additional resources to kind of wrap up. So if you haven't heard of Atomic Red Team before and you listen to this, it's our framework for testing security controls. Vendor neutral, it's a free tool on GitHub. Atomic Red Team IO is really the cool place to land if you want to get more information. You jump on either GitHub or Slack. From here, it's really your tool to go in and use to download and exercise your tests in any way. Mike and I really like some of the artifact tests that are in here to automate testing. All of these are backed to MITRE. So if you have a particular technique you're interested in, so if you, like today, we looked at T1090, you can go look here at our test, and we have a very, very simple test setting up a scheme and a proxy using, I think this is a Mac and Linux test. We'll probably add some more here because once we identified this as that top technique in the report, we realized we have some gaps in our testing coverage. So, but again, all of these are mapped back to MITRE ATT&CK, which holds that data source. So
yeah, we also, Casey, if you want to flip back to our Invoke Atomic Red Team, at least the PowerShell framework. So yeah, we also have under execution frameworks there, we have Invoke Atomic Red Team. And so this is just a really, really awesome way that you can get started with Atomic Red Team. It'll pick up all the techniques for you, and everything that's in the framework today, you can just bring it up through PowerShell. You could generate the test, you can execute the test. So it's a really great way just to get started with it, start learning how to use it, and contribute back.
Awesome. Yeah, definitely. Yeah, definitely join some of the things going on in the Slack channel. It's pretty focused specifically around the atomic test, but we love to hear feedback. If you're new to security and you want a place to start, we have a bunch of gaps in our tests. So we always like to see people writing tests. It's a great way to learn. we'll help you through, checking it in and getting it approved in Get. So yeah, anyway, awesome. Well, I'm going to close it out then. I think if that's all we got, Mike. Thanks for attending, everybody. And hopefully these are helpful. Again, provide us feedback, either research@redcanary.com, ping us in the Slack channel. Let us know if we can add or improve these in any way. So thanks for your time, everybody.
Thank you. Y'all have a good day.